Assalamu alaikum, sir. Yeah. Yes, sir. So speaker is
Walaikum
also
assalam, madam.
speaker will be also joining soon. He has messaged me. Yeah.
Am I audible?
Yes, sir, you're audible. Sir, the speaker is
Mr.
joining.
John,
Just had a talk with him. He is logging in.
Mr. John, how many registration is there for today's webinar?
Yes, sir. I didn't get you. Pardon me.
I was just trying to ask Mr. John about the number of registration we have for today's webinar.
No, only 36, sir.
36.
36 only.
Okay.
Yes, sir. Thank you, sir.
Zahir Khan, sir, shall I start with the session?
Yes, madam, sure.
Yeah. Assalamu alaikum wa rahmatullahi wa barakatuh. A very warm welcome to all the dignitaries, our guest speaker, and participants for this online webinar. I request Professor Rafi Khan, sir, to recite few verses of Holy Quran.
Okay, thank you, madam. Am I audible?
Yes, sir, you are audible.
Okay. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين. الرحمن الرحيم. مالك يوم الدين. إياك نعبد وإياك نستعين. اهدنا الصراط المستقيم. صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. صدق الله العظيم. Thank you, madam.
Jazakallah, sir. Very good morning, respected principal, sir. I hope he's here. Dr. Ganesh Kame, Vice Principal come NDLI Club, President come HOD of Civil Engineering, Professor Zahir Khan. Our renowned guest speaker for today, Professor Lokik Salvi from Thakur College of Engineering, Mumbai. Secretary of NDLI Club, Mr. John Abram. Dr. Ibrahim Sheikh, our active member of NDLI Club. Very good morning to all of you. I myself, Tarannum Sheikh, and you are watching another session of MHSCC NDLI Club hosted by MH Sabu Siddiq College of Engineering, Baikla. Today's webinar is the fourth event of this club in this year. We appreciate each one of you joining today, and we do hope you're joining these webinars as enjoying these webinars as much as we are enjoying hosting this for you. I request our Professor Zahir Khan, sir, to give some opening remarks for the event for today.
Am I
Yes,
audible?
Professor Zahir.
Am I
Yes, sir,
audible
you
now?
are on.
Okay.
You are on.
Very good morning, one and all. At the outset, I welcome you all to the webinar on innovative engineering solution for sustainable water conservation in residential areas. It's my pleasure to welcome Mr. Lokik Salvi, Assistant Professor, Thakur College of Engineering, who is today's guest speaker and a resource person. As you know, today's topic is very, very important. The word sustainable means to meet the needs of the present without compromising on the requirement of future generations. Water conservation means practice of using water efficiently to reduce unnecessary water usage. Thus, the topic of today's webinar, sustainable water conservation in residential area, is all about different techniques to reduce water usage, particularly in residential areas. So we do hope to have a very good interaction in our question answer session. And I welcome all the members of NDLI Club, our in charge principal, Dr. Ganesh Kame, and all the participants. I wish all my best to all the participants. Thank you, one and all.
Thank you, sir, for giving such motivational opening remarks. As all of us know, water plays critical role in our day-to-day life, right from home to the industries. So in today's webinar, one such use cases will be discussed in detail by our renowned speaker, Professor Lokik Salvi. Let me now introduce today's subject matters expert. Professor Lokik is a renowned speaker and research scholar, awarded with various certification in Google Platform, Microsoft Azure, cloud computation, and Atal certifications. He has completed his bachelor's and master's in computer engineering from University of Mumbai, and he is currently pursuing his research from RAIT, that is Ram Rao Adik Institute of Technology. His domain of interest and research include cloud, data science, databases, machine learning, and IoT. He has been working on research related projects for water conservation for the past 3 to 4 years. In due course, he also received a research grant from University of Mumbai for his contribution in water conservation. Indeed, a great achievement, sir. He is primarily skilled in tools, namely Armbed, Android Studio, Wireshark, and Watson IBM Labs. He has published 11 quality papers in reputed conferences and journals. He has successfully completed certification in cloud and deep learning. He is accountable for research in futuristic water conservation technique using control systems. So without further ado, I will hand over this virtual stage to Professor Lokik so he can take on his presentation. Over to you, sir.
Thank you, ma'am. I hope I am audible.
Yes,
Thank
you
you,
are
ma'am.
audible.
Thank you, sir, for your kind words. I just share the screen.
Yes, you can, sir.
I hope the screen is visible. If anyone can confirm, share it again. Okay, I hope it is visible.
Yes, sir, it
Yeah,
is.
it's good.
Okay, yeah, thank you. Good afternoon to each and everyone. And the topic of our discussion today will be some innovative engineering solutions for sustainable water conservation in residential areas. Now, before we jump into the thick of the matters, first we'll talk about water as a resource, and we'll see what is the utility of water as of now, as of date, in the urban areas to start with. So we'll want to fix on the background of the subject topic before we move on to the solutions for water conservation. Now, talking about water, now these are some prerequisite but very fundamental facts about water. We know that for a fact that water is a very important natural resource, and it is very essential for all our living on this earth. Talking about its significance, we know that the 71% of the Earth's surface is covered by water, and out of which only 3% is the fresh water, which means at our disposal currently we have only 3% of the total water out of the 71% that is the water reserve on the earth, which makes water a very finite resources, and the essentiality of water makes it a very significantly embedded resource, which means the availability of the water is going to be an issue in long term. Till now, the country or as a globe, we have been subjected to a lot of issues related to water, and which would be a big red flag for us to understand whether to use the water judicially or not. Which means, in order to keep this ecosystem going, water is going to play, or water plays a very crucial role in socio-economic factors and to maintain the biodiversity. Now, this is just a representation of how water is important in terms of applications of water. Now, we know for a fact that India as a country is an agricultural country, and for which water is going to be of utmost importance, and which is why the the entire talk about the water or the entire utility about the water is always subjected around the agriculture. But now the things have changed drastically, because if you look at the other applications as well, the applications of the water apart from the biodiversity have increased, and we now are shifting our goal, or are shifting our research towards the industrial and domestic water supplies as well. Because as human, as civilizations, we have always settled near the water, and the urban areas these days have found a huge utility of water in terms of the applications, because of the increase in the socio-economic factors or the globalization or the other technological advancements. Which is why the water is used on a very vast extent. But the way the water is used is a still big question mark. And to talk about the sustainability, the bigger question here is the water being used properly or not? Now, some facts about the water that would help us to increase the gravity of this topic. As we know, the 97% of the total water is the salt water out of the 71% that we just mentioned. So, which means only 3% of it is in the fresh water form for us to use, out of which two-thirds is locked in the ice caps or glaciers, which, obviously, for a fact, after the global warming effect, we have been making use of that water as well. So, which means only 1% of water is readily accessible for human beings, and that the remaining 2%, which is in the caps or glaciers, which is the otherwise intricate reason behind the global warming. So, which is why we can say the total water at our disposal is very less. Which means if you want to sustain on that much of water, we need to incorporate recycling. We need to incorporate some techniques, some innovative techniques, which would help us to reuse the water again and again. Looking at the current scenario of the entire world, we could say that the water scarcity is a very big problem because of the availability of only 1% fresh water. Which means, according to the statistics, more than 40% of world population could face water scarcity just about the or say that the say that the to the water supply. Now, the question is, if we talk about sustainability, we know for a fact that we have just 3% of water to be used. Water scarcity, and this is not on the basis of the statistics of 3% or 97%, but this is on the basis of the statistics for water usage. Now, when we talk about water usage as a whole, we know that the rural areas are going to have huge water reserves as comparative to the urban areas, not just because of the geographical aspects or geographical well-being of rural areas, but also because of the way the rural areas have been placed demographically. If we talk about urban areas, for that case, we can say that the urban areas are highly populated, densely populated. And even if we say that for a fact, if we bar off population for now, the way the water is being used, the technologies which have been disposed to use the water are increasing day by day. So every technology, if we talk about, even for the industries or even for the residential areas, these days we need water. But we have always talked about the amount of water that has been used, but we have not talked about how the water is being used. So one of the representation on this slide will give you a clearer idea about how water is being used or how much amount of water is being used at our home itself. Because we talk about the unit economics of the entire urban areas, we could start with appliances, and those appliances are just using waters for our convenience. And throughout the years, throughout the last decade or so, we have made a habit, we have made a very bad habit of abusing water with the help of all these technologies or all these things that we have at our home. So which is why what has happened is we have not looked, or we have overlooked over the aspect of water over the or we have overlooked the distribution of water over the year. What I mean by that is during the summers, we often find that we tend to use more waters. But do we think about the amount of water that is at our disposal during the summers? No. We obviously talk about the lakes, or we talk about our applicative, or we talk about the sources of water being filled by the rainy season or by the start of the winter season. But we don't talk about them in the summer season. We think that if it rains properly, we would be able to sustain throughout the year. But mind you, that is a very small, or that is a very shallow thinking. We should outgrow ourselves. We should outgrow our thinking in such a way that we should think about sustainability of water for our future generation. The population is increasing. We're just talking about the rainfall water that has been accumulated into the lakes. We're not talking about the technical aspects which we are introducing every now and then, which are going to abuse water. One such would be dishwasher. So when we talk about dishwasher, we know that in a household which has dishwasher, the amount of water that is going to be used by dishwasher is going to be way higher than any other source. Then would be the flush, or then would be the shower. Instead, we are so technologically advanced, and we have all the infographics with us to understand that it is not advisable to use showers, or not advisable to use dishwasher. But just for the sake of convenience, and because we have a sugar coated information about the lakes being filled completely, we have been abusing water, and usage of the water has increasing by many fold in the urban industries and the residential areas. So talking about the entire water cycle, this is what we know for now, and which is why we have been bullied into thinking that the water sources are completely dependent on the residential areas, and we need not think about, or they're only completely dependent on the rainfall, and we did not think upon how the water is being used. We just think about how more and more water can we store, how more and more water can we get from the rainfall, do we plant more trees, and so on and so forth. But the crux of the matter lies in how do we actually treat the water. So what we have in front of us is the basic representation of how the urban water cycle looks like for now. And we start that with the water abstraction techniques, which are used to abstract the water from the lakes or other sources, then are further treated, then are stored, and then distributed. And then on the bottom side, we see once the usage is done, we just treat the water and throw it back to the sources in a way that we complete a cycle, and we feel that how much of water we have used has been given back to the sources and then can be abstracted. But the thing is, this entire thing that we have is very complex. If we try to understand this thing, we know for a fact a lot of water is going to be leaked out. A lot of water that has already been used is used to such an extent that it will take lots of rupees to recycle it. And which is why we just don't think about recycling or reusing the water. We just throw it back to the original source, which then ends up in polluting the entire water. So what currently we are trying to do as a city is not in good sense, and is not in good context to the sustainability of the water. Now, just to give you a review of how the water usage in the urban areas, and how the current scenario of the water usage in the urban areas has been, we know that the urban areas are increasing. Number of urban areas, every city or every district is now trying to urbanize itself. And by that, we mean that we are trying to have more industrial estates, we're trying to have more residential estate, and obviously the population explosion has been a boon in that case, that we are able to increase the urbanization, because of which every unit in the urban areas, or because if you treat the urban areas as a unit, the number of units are increasing, which means the number of water units dedicated to that particular urban area have to increase, and that is directly proportional to the population. Because more the population, more would be the need for the water in all particular aspects. And we have been using engineering, we have been using all our knowledges to increase the storage of the water. But one fine day we are going to run out of water, and then the storage would be of no use. And for a fact, there have been a lot of biological aspects to bring about something which is closer to chemically like a water. But frankly speaking, that is not going to be, or that cannot be a long-term solution in this case. Now, secondly, because of all these activities, all these industrial activities, and for that case, we can consider afforestation as one of the major contributors here as well. The climate is changing. Now, one of the study that was said that previously in Mumbai, in the state of Maharashtra itself, it was thought that we got a lot of rainfall in the seasonal period or in the rainy season period, and only 1 to 2% of the rainfall came from the non-monsoon or the non-seasonal period. But if you look at the facts, or if you look at the statistics right now, or even for that case, you all or we all could advocate for this. We all could speak for it, and we could say that the amount of non-seasonal rainfall has increased. So we can say that climate is changing, and the amount of rainfall in the monsoon period is decreasing. And somehow the seasonality of the water, the seasonality of rainfall, all in all, has changed, which is a big danger, because till now everything that we had for water depended on rainfall. So we knew for a fixed period of year we're going to get rainfall from all the natural sources for that period, and we would rely on the seasonal period for that particular water, or would rely on the seasonal rainfall throughout the year. But now the climate is changing. With that, the population is not helping as well. So geography is changing, population is increasing, and we are surely going to be in a fix to think about sustainability as an issue for water. Now, this thing on the slide, the figure number one gives us a brief idea of how all the seven cities, all the major seven contributors of the cities, and their staggering according to the usage of water. And this is just the analysis of these seven cities on the basis of the technological aspects that we have leveraged on our residential areas. I mean, if you talk about the Mumbai city, per day there is 2,900 MLD, that is liquid discharge of the water. So if tomorrow I have to keep Mumbai sustaining, if I have to keep Mumbai running, I have to have this much amount of water or this much amount of liquid discharge, which is going to grow up by 71% in the year 2041, because the population is going to increase. But mind you, population is not the only thing that is a major player over here. The climate is changing, the technological aspects have increased, the population has increased, but with that the climate is deteriorating as well, and that could reach to 3,750 million liters per day to keep Mumbai running. Now the question then would be that the amount of water that we are getting from the rainfall is decreasing, the amount of water that we need, the demand is increasing, so there's going to be a huge dip in the supply, but a huge inflative increase in the demand. Now, from where is this demand coming from? This demand is basically coming from all the technologies that we have leveraged in the residential areas. Would be like bathing, washing clothes, drinking, cooking, or the sanitary habits that we have, cleaning the house or washing the utensils, which we consider to be the basic aids and basic necessities of every household. But the way the water is being used has to be talked about, because for a fact we know that we can never get over these activities: bathing, washing clothing, washing clothes, sorry, or drinking, cooking. We can never get over these activities. We surely need to talk about the optimization in a way that we still keep on doing these activities, but in a better way, to ensure that the water that we have at our disposal is not going to increase in number, or is not going to increase exponentially, but we are able to suffice in the amount of water that has been disposed out during the rainy or throughout the year. Now, this is just a comparative analysis between which gives an alarming effect between the urban and the rural areas. If you just talk about the entire system of residential areas in the urban, they all are piped, right? Now, what do we mean by piped is obviously we draw pipes from the sources of the water, and if we are at our convenience. Now, what happens is, because of that, because of these piped dwellings, one major factor, which is leakage of pipes, is going to contribute to wastage of water. So that is the amount of water that we did not even use and has been wasted, has been degraded, has been abused, and then it has not been even reused, because we feel that has been wasted out, that has been leaked out from the pipes. Next is the use of flush, or the pour flush for that case. 53% of the water in our residential areas placed in urban cities goes to the pour flushing. Similarly, washing the hands, because in a day we do a lot of activities, which means 79% of the water is being used for washing the hands. And then, because now we do not, obviously we live in a nuclear family, but still we live in a convenient space, which has increased the number of rooms, which has increased the utility of kitchen. the entire definition of kitchen has increased. Now, kitchen is something or is a place where we are 24/7, which means the separate taps in the kitchen or separate taps all over the home are contributing to 56% of the water usage. Now, this is a comparative analysis, which means somewhere in the rural areas, the habits are not developed enough, because of which the usage of water is very less comparative to the urban areas. But we would keep it the other way around as well. Somehow we have regressively taken up some habits which are haphazard or which are very hazardous to the usage of water. Three of which could be the piped dwelling system. The next would be use of pore flush. Next would be the use of frequent use of hand wash or some detergents, or the habits that we have come up with. I'm not saying that we have to change these habits and we have to move towards unhygienity, but the way the things have been done in the urban areas are really alarming. So, which is why we need to develop some water management system. We need to talk about some innovative techniques which are going to help us to sustain or help us to be the way we are and still keep on using the same amount of water. Now, when we talk about sustainable water conservation, as we said, we just need to change our habits. The population is going to grow. The amount of water that we will be getting in a year, we don't have any direct control over it. Which means the problem here is that as we do have no control over the natural resources, and moreover we have no control over the direct control over the population as well. Can we change the entire water management system in such a way that people become knowledgeable enough, people try to appreciate the sustainability of water and then move towards water conservation? Because for a fact, we have been talking about water conservation through a lot of activities, through a lot of programs, but we have never talked about the reason behind water conservation. It is not that the population is growing, so we need to conserve the water. It is not because the amount of water that we'll be getting at our disposal from the national resources is going down, and which is why we need to conserve the water. These are not the only sole contributors to water conservation, but we need to ensure that everything that we need, everything that we would be doing would be increasing exponentially. As a civilization, we are going to grow, so we need to incorporate sustainability somewhere. We need to incorporate recycling somewhere. We need to incorporate protection and restoration of water somewhere. We need to adopt some practices, we need to adopt some technologies which are not going to hinder our progress, but which are going to help us to increase the amount or increase the utility of the water, all in all. So the goal here is to conserve water in a manner that is environmentally superficial, in a manner that is economically and socially responsible, for which we need to change our habits, and then we talk about sustainable water conservation. So as an individual, we should educate ourselves, which is what we're doing right now, and we should pass on this education to all of the communities, to all the individuals, to all of the industries, in order to set up such a water management system or such a water distribution system, which is quite conventional and very different to the traditional approach that we follow. So the basic takeaway from this slide would be that we should first talk about how to sustain, how to have the countermeasures, how to have the measures to sustain with the less amount of water, and then move towards the conservation techniques. Now, to mention about the innovative engineering techniques, now because this is a very technical aspect to the discussion. Now, from here on, we'll be having a very technical aspect to our discussion. When you discuss about some techniques, out of these techniques, we have been there for a while, from the time when we have talked about conservation of water. But now we need to talk about how to sustain or how to sustainably conserve the water. So, which is why I've listed down 6 techniques, and in the end, I'll be discussing about one of the research that has been going on the water usage pattern. Now, to start with, I'll just enlist the techniques which have been used to sustainably conserve the water. First is obviously the rainwater harvesting system. Next is the grey water recycling. Next is the low flow plumbing, and the fourth one would be smart irrigation, permeable paving, and the xeriscaping. Now, in this technique, I have taken into consideration all the innovative engineering solutions which could be leveraged to rural, urban, or something which has some house which has a garden, something which has irrigational area around it. Everything, every usage of the water has been taken into consideration for this case. Now, firstly, talking about rainwater harvesting, we are pretty much primatized to rainwater harvesting. So we know that the water that we get from the rainfall should be stored somewhere. But that is a very traditional approach. Because as you said, we are now moved towards the pakka makans. We no longer live in a kacha makan, which is a tradition, or which is traditional household, which was a traditional household that is there in the rural areas. Now we live in an area which is a complex pipe network. Sorry. And which is why the technique of rainfall harvesting should change as well, because we are not just serving one house. If you just talk about any one residential complex in the Mumbai itself, it is going to have hundreds and 200 households, which is going to have more than 500 residents in it, and it is going to have a complex connection of pipes within it, which means even if we happen to harvest the rainwater, the amount of rainwater that is being harvested is going to play a very important role, and the distribution of that particular rainwater is again going to be very instrumental in deciding whether the rainwater harvesting is actually a thing to be done or not. So what if we define the customer pattern? What if we define the pattern of usage of water? What if we define the pattern, or the if we define the sentimental and the socioeconomic factors of the, yes sir? Sir, can you see the slides now? We have changed the slide this way.
Sir, zoom the presentation slide on the
Okay.
presentation view.
Slideshow will do. Slideshow.
F5.
I was in slideshow.
F
Yeah, it was in slideshow. It was in
Slideshow.
that's
slideshow. Okay,
F5,
I
I
will.
think.
Now this is in the slideshow. I hope it is visible, sir.
No, no. It is
Sir,
visible,
it's
but
not
it
in the
should be
slideshow.
presentation
Okay,
mode.
let me try again. Is it now, sir?
Yeah, correct. Yes, yes.
Okay, thank you so much. Okay, talking about the rainfall harvesting, we just mentioned
Thank you.
that we are living in a pipe, we're living in a very complex area right now, and there are a lot of takers for the water on the other end. And building a small or a traditional rainfall harvesting system, or a very traditional, for that case, a tank, which is going to collect all the water from the rainfall, is going to be a difficult solution, because because the demand here on the other end is very high, and the supply has to be in a way and it justifies the demand. Now, how do we justify the demand for a case that we know that these pipes are going to have, or these pipes are perennial, and they're going to have water throughout the year from the BMC or from the other sources that have been supplying water to us? But in that case, if we happen to fix that rainwater harvesting system somewhere, we would be self-reliant, and we would not be reliant on the amount of water or the water that has been supplied from the municipal corporation to us. I'm talking about the inbuilt rainfall harvesting system in a society or a complex. So, which is why we would be saving on the amount of water that is being used. Now, because for a fact that we know that we feel that we have unlimited supply of water from the BMCs, which is why we are more prone to using the water in all unjudicious manner. Which means if we substitute the entire system with a rainwater harvesting system, we then have a scenario in which we feel that the amount of water on our disposal, at our disposal, is prefixed, and that is completely dependent on the rainfall that would be coming, or that we would be receiving. Which means that we have a thought that the rainwater is being stored in some tank, and that is completely dependent on the rainfall, which intrinsically, sentimentally, brings about a sense of responsibility in the use of water. Wherever the water usage is higher than the amount of water that should be used, we can rely on the BMC or the local body water supply. But wherever we talk about a house which has a garden, or for that case, all the small needs where we need water, we can rely on the rainwater harvesting system. Now, having water in our compound, in our complex, is going to set up a complete maintenance or surveillance kind of atmosphere in which we would be monitoring the use of water. We would be comparing our usage with the amount of water that is left, and accordingly we will then curbing the use of water according to the needs and the supply. Now, types of rainwater harvesting, now these are all technical types, not the traditional types of water. First is obviously the gravity fed system, in which we are going to collect the rainwater from the roofs, and then we are going to store the large tanks. Depending upon depending upon the height, or depending upon the floor or the storage of the house, the amount of water would be supplied. So I'm talking about generally in some areas where we have a bungalow or a 2-3 story bungalow, it is basically good to use a gravity fed system, in which the depending upon the gravity or depending upon the story or depending upon the height of the house, the water would be supplied. So we would have all the major users of water at the bottom or at the ground floor itself, and the amount of water that is being used on the top floor would be less, or compared significantly less than the water that is used on the bottom floor. And this would help us to curb the overall usage of water. Then is the pumped system, and these systems are only used whenever we have some highly significant applications, like the washing machines or an outdoor facet or a dishwasher in that case. Then we move to the modular, which is something that is closer to a hybrid system, wherein we would be connected to a large storage, that is some rainwater harvesting system which has lot of water stored in it, but it is connected to some fabricated model. It is connected to some IoT device, which would then give us a view or an overview of water that is being used. Or in that case, we can define the usage of water beforehand and only prerequisitively give water to the user. Next is the in-ground system, which is used in a lot of areas in the Mumbai as well, where a well or a tank is been set up, and those things are used in the off seasons. So when the rainfall comes in, the water in that particular thing is not used, and after which in the summer season, when we have a huge delay of water, if we have a huge overlay of water, in that case those particular in-ground systems could be used. Now the thing over in-ground system is that here we have to be habitual, or we have to be very strictly cognitive to this case, that we only use this water during the off seasons and not during the rainy season. Next is the hybrid system, which take into consideration or which is actually accumulation of all these systems that we just talked about, and that is something that helps us to move towards a sustainable water. Now, an example for hybrid system would be, now for a case, let us say, for instance, we talk about a house which has, or if, for instance, we talk about a building, let us say in Mumbai, which is 3 story, and it is all piped. It receives BMC water, and it has a hybrid system of rainwater harvesting as well. Now, depending upon the water that will be needed, I'll be using the amount of water, and that will be metered through IoT sensor. On each and every level, all the sensors would be fitted on the pipes that would be carrying water in and out of that hybrid system, which means we'll be taking care of the leakage as well. With that, we'll be taking care of monitoring as well. And the wastage of water in this case is going to be very less, because the hybrid system is going to monitor. Now, this monitoring is subsequently added with the grey water recycling, which we'll be talking about in a while. But just to give you an idea about that, would be that we would have a small treatment plant which is going to treat all the grey water that we have from the house, and the treated water would be put again in the tank. So in a way, what we're trying to do is, whenever we need the water, we are using it from the tank in a monitored manner. So we know who is using how much amount of water, which minimizes the overuse of water. And that monitoring will also keep a check on the leakage of pipes. Once we have the water in our house and it is used, it could be then treated, because that used water is generally treated as a grey water, and that grey water could be recycled using some techniques that could be, that could be some arbitrary technique as well, and that grey water then would be fed into the tanks again. Now this creates an entire system which is quite visible in this slide on the right hand side as well. So we are trying to use and reuse the water in a monitored and an analytical way using a hybrid system. Now, subsequently, as we mentioned about grey water recycling, it could again be another technique which has come up as a boon for recycling the water. Because if you look at the statistics, previous statistics that we had in the second or the first slide, we mentioned that in the urban areas, we are always there's a big gap, or there's a big overuse of water in the kitchen or in the sanitary areas. So which is why what we have as a intrinsic thought is that this water that is used in kitchen, or in case our washrooms or toilets, this gray water is of no use to us, and we need to dispose that water. But when we talk about recycling the water, as we know that 50 or 70% of water is being used in our kitchens and in the washrooms, what if we can recycle the 50 to 70% of water? It is going to increase the use, it is going to increase the storage of water by 50 to 70%. Now, when we talk about the grey water system, there are n number of grey water systems that we can use. First, we start with the basic grey water system. It is just diverting the grey water from the kitchen or from the washrooms to a storage tank or a barrel, store it there, and treat it properly. Branched would be throughout the house, because we live in the pipeline system, which means that each and every pipe that has been provided to the kitchen, or would be any other room in the house, the grey water from each and every unit is cumulatively collected and stored in a certain area. Now, further that would be that if we take example of the some gray water which is not as significantly contaminated, something that could be used for washing our hands, or something that is not so significantly a big contamination source for the water, could be reused in some part of garden as well, could be reused for some car washing centers, or would be used for washing the car that is parked in our own parking. Next is the pumped system, in which we can use a pump to distribute the grey water in a different house. The entire idea here is to primarily talk about those recycling techniques which take no significant economic cost. That is using the least grade water, that is using water that is not so significantly contaminated, and that could be used for washing a car, as I mentioned, or for gardening, or for watering some of the household plants itself. So that would serve the purpose, and the water would not be wasted. Next is talking about some gray water, or that part of the gray water, or that quantity of gray water which has been contaminated to such a level that it cannot be directly reused. So I'm talking about something that comes out from the toilet flushes or laundries, or some non-potable sources of water from which gray water has been found. That has to be fed into a treatment plant, and it has to be recycled. Now, recycling and treatment, this thing is as good as, or as goes near to the water that we receive from the seas or from the lake. Now, mind you, this is not literally same, because the water that we receive from the lakes and the other sources of water, they are much more clean and hygienic, or much more uncontaminated than the gray water that we just mentioned. But by increasing the intensity of the treatment, we can achieve recycling. It is not that the recycling cannot be done. Obviously, whatever kind of gray water that we get could be recycled, could be treated, and on the grade of treatment, on the intensity of treatment, their further application could be decided. If it is not properly treated, it could be used for gardening, or it could be used for washing our cars. If it is properly and intensively treated, and it is converted into some potable form of water, it could be put again into the house for reuse. Next is low flow plumbing. Now, the thing is, now when we talk about low flow plumbing, this entire diagram gives a basic idea about low flow plumbing. What happens is, basically, when we talk about the plumbing, when we talk about the entire pipe system at our home, what we know is, for that fact, when we set up our house, we are very significantly aware, or we are very deep into the thoughts about plumbing, and setting up taps, setting up proper toiletries, setting up proper washroom, and setting up sink techniques or sinkage in our different parts of house. But what if we can fix this? Because a normal flush, as mentioned, is going to take huge amount of water, 66,000 gallons per year of water. But if we use a low flush, which is a technique of using minimal water in our flushes. It is going to save up to 73% of water. Now this, if I talk about this in a very technical aspect, the amount of water that we are disposing in our flushes, in our sinks, in our washing machines is completely unmonitored. It has been standardized to such a level that every toilet, irrespective of its size, use, every washing machine, irrespective of its type and use, will get standard amount of water by the which has been standardized by certain amount of constructor or certain amount of people who are using that particular. But what if we standardize the entire plumbing system, or we standardize the entire flow of the plumbing? If we are able to fix the flow of the plumbing in a way that we decrease the number of flushes, we decrease the time of the flushes, we decrease the size of pipes that are serving water to these kind of things, we would be able to save a lot of water and ensure and keep doing the same things at the same rate. And this is what sustainability is all about. It is not going to be a obstacle to our daily routine, but it is rather going to allow us keep doing the same things, but at the same rate, but with the use of less water. So low flow plumbing fixtures would help us to decrease the entire water usage. Now, what do we do to integrate this low flow plumbing fixture? The basic thing is, first we need to study the entire water distribution system, or the entire mapping of the pipes at our home has to be studied. From that, we know that for a fact that the taps or all the sources of water are going to take huge or are going to take majority of water for that has been allocated to the particular house. What if we substitute all of them with low flow pipes? What if we use conventional toilet techniques then or over the traditional toilet techniques? We are going to save water in gallons, and that too in per day manner. We can give up the dishwashers and instead use some of the traditional dishwashing techniques, which would sound as a big complexity, a big hurdle for some households which have a lot of people at their house. But even today, the dishwashers come with a low flow plumbing. So this is something that goes near to the stars or the use of the 5-star rating of the electricity that we usually find on our electric appliances these days. So whenever we go to a shop and ask for any plumbing techniques or fixtures, we should ask for low flow plumbing, which technically and non-technically or quite literally is going to reduce the usage of water or reduce the outsource of water by 30 to 40%. Next is a smart irrigation system. Now, this is something that is discussed a lot because of after the advent of the IoT, we know that everywhere we can set up a sensor, and that sensor could be controlled using a microcontroller as well. Now, setting up the sensor, why? A basic requirement of the water first has to be studied, because what we do is we are very emotional about the environment, very emotional about the trees that we plant around, and which is why what we do is we happen to uncannily or we happen to uncyclically water them, unproportionately water them. Do not study the need of water. We just keep on we just keep on supplying the water to our plants. Which is why if we could have sensors that could tell us how much amount of water is needed for the plant, or for that case, how much amount of water is enough for a certain area or certain irrigated area, then it is going to help us to optimize the usage of water and finally reduce the usage of water. So if we can set up some control over, just as we said in our urban areas, we need a controlling parameter about which we'll be talking about in a while. But if we just happen to control the entire irrigation area, now irrigation area, why to talk about a smart irrigation system for cities is because we have gardens around. Those could fall under the irrigated area. So we need to water them. Instead of watering them with pipes habitually, we could have some irrigation techniques which might help us to cut down on water. But if we can tech enable them, if we can have some soil moisture sensors, if you could have some weather based controllers, if you could have some water flow meter, if you could have some mobile apps or zone based watering as mentioned, we can actually we can actually monitor the requirement, the demand of the water, and only accordingly supply, which could be manual or automated as well. Now automated irrigation means, obviously for a fact we know that if we know how much demand of water is there, we would supply, or we would have to supply that much amount of water, which could be done through, again, with the help of IoT and sensors or microcontroller. That is something which is easily done or could be easily applicated on these kind of things. Now, if we talk about the two things at the end, that is the permeable paving and the xeriscape. Now, these are quite aesthetic in nature, as in, if I'll just give you a representation, this is how permeable paving would look like. Instead of having blocks or simple concrete at our societies or around the areas that we live in, instead, if you could have a permeable paver or paver blocks as we know, so if you could have a permeable paver which are going to help water seep through it, because now we want to have a sustainable conservation of water, which means every drop of water, if saved, is going to be very important, right? So if we talk about the permeable pavers, they are going to help us to seep the water inside in, and that water could be reused again, and that actually sets up the relationship with the gray water saving as well. Because all this water that we have through the permeable pavers would be a gray water. And depending upon our understanding, or depending upon the usage of water further on, or depending upon the treatment of this gray water, we could reuse this water in some or the other way. Or even if we talk about the advances in the gray water recycling, we can treat all types of gray water to such an intensity that it becomes potable again. And this is something that is seen in many upcoming projects, or in in the last decade or so. This has been taken into consideration by all the builders, by all the construction people as well. Next is the xeriscaping. Now, xeriscaping in a way is adding more and more landscape around us. Now, this is obviously not a technical aspect, but yes, it has now been added to the innovative measures for saving water. How? Because we, as human, have always had this habit of having small plants around, and those plants are obviously somehow going to save a lot of water for us. What if we convert the entire place that we live in, as in the society or the community that we live in, into a landscape which is a green landscape, but obviously a synthetic one? What happens then is, if we plant more trees around us, in and around the place that we live in, the water seeping capability of that entire place is going to increase, and that is going to increase the amount of groundwater as well. This landscaping is just having small plants, or just incorporating the permeable pavers that we just talked about. And if we happen to do that, we are ensuring biodiversity that is taken care of. We are ensuring that we're promoting more and more reuse of water. The fact that we are reusing the water is going to increase. And for a fact, if you just talk about xeriscaping, quite literally, the maintenance of xeriscape is very less. And this is a very booming thing out in the West, and it is coming somehow in our country as well from the West. It is cost effective, and but obviously the upside would be that it increases the property value as well. So we want to convert the areas that we live in into a xeriscape, into a synthetic landscape which has some small plants, herbs and shrubs around us, which are going to stop the water to flow out of our community or out of our society. It can be seeped into the rain harvested tank that we just mentioned in the first place. If they are, obviously they would be a gray water, they could be treated and they could be recycled. So this is how we have just completed one big cycle, in which we talked about the rainwater harvesting, then we talked about the pavers, and then we are now on the xeriscape. So everything that we've discussed till now is somehow related to each other, and this is quite very significant when we talk about from the view of the urban areas. Now, one thing, as I said, is that we should take care of is the water demand function. Just to give you an idea about how important this water demand function is, let us talk about the traditional technique of calculating our bills. Today, We live in a society which has, let us say, 100 people in it, and we get X amount of water. The amount of water that is being used is considered as X divided by the total amount of people who are using it. And then we get a per unit bill for each and every person who falls under that 100-person category. Now, this is a very traditional way of calculating a bill. It would be that some of the person or some of the families from that 100 families might have used more water than the other families, and we have just taken into consideration the amount of family members per or number of members per family, which surely is not a good indicator when we talk about usage of water. Because for outsider, quite literally, it feels that the number of family members are directly proportional to the usage of water. As a family, I'm going to have some demand of water. I need to jot down a function which has parameters which tells me that for a particular family, what are the parameters which are forcing that family to use the water and then to overuse the water. And what I'm talking about is this. On the left hand side, we have a traditional function which says that the amount of water divided by the number of families. But what if I want to, and if the entire discussion is that how can I protect, conserve, sustainably use water? I need to understand the pattern of the water usage first. Till now, we have discussed how can we mellow down the use of water, how can we recycle the water. But now we're talking about understanding the use of water. And that is not surely dependent on just one factor, that is the number of family members. It is dependent upon the water consumption, and that water consumption has further or could be further divided into n number of parameters, one of which being the water price. If we increase the amount of, if we increase the water price, somehow we'll see that there is going to be some change in the usage of water. Next is the type of the household. As we said, we live in the urban areas in a pakka household, which means we have the opportunity and we have the convenience of setting up a lot of things in and around the house. So which means the household type is directly proportional to the use of water. If we are living in a pakka household, we might have more opportunities to abuse water. And next is obviously the extrinsic factor, which could be a climate, and which is fairly given that in the summers we are going to use more waters than the winters, right? So this is how I propose that we should be able to devise a water function. And if we are able to devise a water function for each and every area and then relate it to the amount of water that is being supplied, we'll find that there is a big gap that we have missed on. Now, parameters that are affecting the consumption of water should be first taken into consideration. We should just not say that the total amount of water is dependent on the number of family members. In this case, we can say the number of family members into the water consumed is the traditional approach. But we have to incorporate the usage of water due to the socio-economic factors. We have to incorporate the usage of water because of the festivals for that case. We have to take into consideration the background of each and every family member, because that is going to significantly affect the usage of water. If we talk about having more kids at house, it is going to have X amount of water usage. If we talk about having more old people in the house, it is going to have Y amount of water usage. So which means the number of family member is not just the only pointer on which the entire thing depends, but the reflecting factor would be the consumption of water on the basis of socio-economic factors, or the entire aspect behind the family members, or the background of the family member has to be taken into consideration, and only then we'll be radically talking about the consumption. So there is a big gap in the consumption, or there is a big gap in the measurement of water consumption. Now this could be a proposed format. When we talk about usage of water, we use water and then we measure it, which is why we fall behind in our countermeasures. Let us say I use X amount of water, and then I say, okay, out of X, there is one parameter X1 which shouldn't have been used, and that is why it is leading to overuse of water. But what if we can prefix those X1, X2 parameters which are leading to overuse, and only find out those parameters which are useful for sustainable water usage, and then add up to get the total amount of water water consumption. So what I'm talking about is, if I talk about a social norms, if I talk about socioeconomic background of that family, I understand how much is the overuse and how much is the proper sustainable factor, or is it a sustainable factor which leads to the proper water consumption. The price and income depends as well. The income of the family and the price of the water that is being supplied to that area is going to affect the overuse and the sustainability of the water. The characteristics of house, as in if the house or the square feet, or if the bifurcation in the house, the type of the house, the area of the house, the locality of the house is going to define the overuse and the sustainable usage of water parameter. And the capital, but obviously all the geographical factors like climate and region is again going to be a clear indicator in that case as well. The key takeaways from this thing would be that when we talk about conserving the water, firstly, or when we talk about sustainably conserving the water, we always prefix ourselves to conserving the water, and we think that there is some kind of source which has to be taken care of, some kind of storage which has to be developed in order to conserve the water. But it is not so. We have to talk about how the water is being used, where the water is being used, and how the amount, after we understand how much water is being used, how can we recycle that water. We should not talk about the sources, bringing about more sources, bringing about more storage capabilities, but rather we should talk about the amount of water that we are using today. Can we use some other technique? Can we improvise the techniques that are using water today to extend a new horizon, to extend a new policy that cuts down the amount of water? The next thing is actually creating a proper overview or a proper data out of this. And that data would have all these parameters. And then through those all these parameters, we can actually frame a hybrid water demand function, which tells me that there is a big need of this hybrid demand water function. Why? Because the population is increasing, the type of population has to be studied, and there are n number of other parameters as well, as in the household, water price, or the climate for that case. So water usage is not just dependent on one parameter, it is dependent on n number of parameters. And we need to study all those n number of parameters. And once we study that n number of parameters, we can then form a water demand function and then compare it to the supply of water that we have. And then only we can say we'll be able to sustain with the amount of water. Because as we said, something at the start itself, that the supply of the water is going to go down, the demand of the water is going to increase. Rather than just looking at this scenario from outside and saying that we need to be sustainable, can we just go into the scenario and say that what is increasing the demand? It is not just the increase in the population, but it would be the type of household, it would be the water prices, or it would be some other extrinsic factor. And if we could find out some factors that could be controlled, then the demand could be curbed down. And if the demand is brought in line with the supply, then we are moving towards sustainable water conservation. So these are the takeaways from the slides that we discussed about. And this is how I feel is the way ahead. That is it from my side.
Thank you, Professor Lokik, for enlightening us with the tremendous knowledge of water conservation and sustainability. Let us take few questions from the participants, audience. Any questions? Yes, participants, any questions? If any questions, you can also type in the messages. Lokik, sir, I have one question.
Yes,
As you said that if it's a bungalow system or an apartment system, there should be a water collection, rainwater harvesting system should be present each and every day. Yeah, I totally agree with it. But nowadays, there is, there are world cities been developing, for example, like Lodha World and all. So those people are not building their own reservoir system for water conservation. They are taking the government or dam or the reservoirs which the government has built. So why don't those people actually go for the water conservation and the reservoir system? Like they are
yes.
having the whole city developed.
Right, ma'am. Ma'am, now if you talk about the traditional way of the water distribution that has been done or that has been followed in the city for that case, is that whenever a builder or whenever a constructor wants to build a city, he'll just think about the land. He'll just think about the aspect of the land, as in all the geometrical aspect of the land, but not about the demographical or the geographical aspect of the land. There should be some kind of handshaking between the PWD and the building or the constructor itself. They should first study the amount of water that is at disposal in the ground level. If that ground level water is high enough, only then they should be able to develop that particular kind of thing. What has happened is a lot of developers, a lot of people in and around the city have developed places, have developed the cities in such a place where they have been calling piped water, or the pipes have been led for kilometers and then they get a water supply, which is not wrong, because after all we want to develop, and this is something that is going to cap our development. But what if we study the ground level first? If we sense the amount of ground level that is there at the disposal and then decide the amount of people that would be living on that ground, it would be a very optimal solution in that case. If not this, if we first build a prototype of the water demand function and then move towards the other activities like building and constructing it, that would be a much better solution to what we have. So currently we're just constructing our buildings and then thinking about the amount of water in lump sum. But what if we have a water demand function standardized for each and every household? Then I feel they would be forced into thinking into that manner, that okay, this is the water demand function, and because that is going to have many parameters, and those parameters would be quite independent and quite unique to the area that they have chosen, and that would give them the amount of water that would be needed by each and every person in that developed area, and multiplicatively or exponentially with the amount of residents that would be living, and then they would take their next decision. So the decision making today does not consider the amount of water into disposal. They just feel that because there is a need and necessity to build the resident, and the water would be made available by the local or the BMC bodies, and we just go ahead with their other plans. So just completely wrong, as you pointed out, and which is why I said we should be proposing a water demand function on obviously a national level or somewhere, which should be incorporated as an innovative practice for the government or for the water department itself, which gives a quite unique or quite a macro level monitoring over the usage of water, and then move ahead with our other activities.
Okay, sir. Any further questions? Any more? There's one message from Dr. Asif Ansari. It is a very good presentation and very much related to my subjects. So he's thanking you, Professor Lokik, sir.
Thank you, sir. My pleasure.
Any more questions? I hope I'll move further. Dr. Ibrahim, sir, shall I? Sir, here I take an opportunity here on this Cognizant platform to wish Dr. Ibrahim, sir, a happiest birthday, who is a very enthusiastic person. Dr. Ibrahim, sir? Hello? Yeah, today is your birthday, I guess. Okay. So Bali, sir, has been getting wishes. Okay, fine. If would have been here, I would have wished him here. Okay, anyway, thank you, sir. So let's move over for concluding our session by the vote of thanks by Professor Rabia Samin. Professor Rabia Samin?
Yes, ma'am, I'm
Yeah.
here. I'm audible?
Yeah, you're audible.
Okay. I, Professor Abia Samin from the Department of Civil Engineering, takes this opportunity to thank Professor Laukik S. Salvi for sharing his immense knowledge on sustainable water conservation technique, which can be adopted in the residential area. I also convey thanks and gratitude to our management director Moinuddin Ahmed, principal Sir Dr. Ganesh Kame for this support. I'm also thankful for our HOD and president of NDIL Club for opening the remark. I hope the students and the faculties present in the section have got enlightened with his knowledge. Thank you very much, sir. It was really indeed a very good knowledge sharing. Knowledge is never ending. It's like an ocean which keeps on adding with different ideas. The way you have given the presentation related to water conservation and how customization can be done, it's really good. Thank you very much. Thank you very much. Thank you, sir. Ibrahim sir, over to you.
Thank you.
Taranum ma'am.
Yeah, ma'am. Thank you, Rabia ma'am. Dr. Ibrahim sir, shall I end with the session? Yes. Sir, should we conclude the session?
Sure, but I think there is one question and left
Yes.
to see the message.
Okay, fine. I'll read it out, sir. Yes, sir. The question is from Siddiqui Kazi.
Yeah.
What are the biggest challenges to implementing sustainable water solution in city like Mumbai, where builders tend to avoid extra cost? Professor Lokik, did you
Yes,
get the question?
yes, ma'am. Yes, ma'am. Now, actually, the problem here is that going in, but at the cost of being unplanned as well. If we talk about the another city or the residing city, which is upgrowing, that is Navi Mumbai, it is a bit planned. And if we talk about a solution for this unplanned city, or if we just bar of the unplanned nature of the R city that is relevant today, we could say that nowadays we have a governing body, that is the RERA, and it takes care of all the aspects of the building. And then there is the PWD department, which obviously takes the other aspects of the other social aspects that are related to the society, or that are related to the construction that is being done. Now, if you previously the idea or the information about the entire building was being made by the builder and not by a statutory body. But today, the idea or the entire information is being made by a statutory body and the builder together. What if the water consumption, because of this, having such sessions or educating people about the sustainability of water, we could somehow bring this information about how the water is being used and what are the countermeasures to improve the sustainability of water. Because for a fact, that this has happened to the automotive industry as well. There are a lot of problems that the e-cars are solving, and because there are a lot of the things that have been shown to the customers these days, people are now moving towards e-cars as well. What if we can incorporate the same thing at the government level with the help of RERA and the other statutory bodies, that they ask the builders to actually take care of these water demand functions and how they're tackling the water issues. So entire thing is about the transparency. If we can increase the transparency, if we somehow increase the transparency between the users and the constructors or the builders, there will be more questions on these terms and they'll be pushed to think about them. And the answer is obviously already there. The research is already been done and the answers are already there. It's just that we don't ask questions, and there is obviously less knowledge or education or transparency amongst the people about these issues. If we increase that, the builders will be forced into thinking about the water conservation, thinking about water sustainability, and the entire thing about, just as we look at the RERA platforms these days, it has every information about when the building was started, how much how much labor was put into it, and when the building would end. Similarly, if you could add just one more column about the water resource that was used for building this building, or water resource consumption that this building would add to our country, so that micro level monitoring is missing. Only after that building is being built, we talk about having conservation. But that is not how we should go. The conservation method should be, before that building is built, we have everything with us, that what would be the maximum amount of people dwelling here. And we already have all the particulars about the geographical area as well. So if we can have some research, or if we can have some analysis done in that manner before the building is constructed, and then decide the scope of the building, and then put it transparently on any platform, that is going to, I feel, that is going to force people into thinking in that manner.
Thank you, Professor Lockett. It was really wonderful presentation. And with that, we come to the end of the session. Thank you.
Thank you, sir. Thank you, ma'am. I would like to generously extend my gratitude to all the organizers, all the listeners as well. And I like to congratulate all of you for having this session, because it is quite an important thing to be discussed on. And we as engineers, we often which manner should be appreciated, should be incorporate water sustainability. So thank you and congratulations, everyone.
Yeah, thank you, sir, so much. Thank you all the participants for giving your esteemed presence for this webinar. I request all the participants and members to leave the meeting.
Thank you, sir.
Thanks a lot, Lokik sir.